wasn't feeling well, right? If you're not feeling well, please don't, please do what you need to do to take care of yourself. Hydrate, get plenty of rest, see a doctor if you need to. Take advantage of the fact that there are a lot of places that are offering telemedicine now. So you should totally, and it works well. My wife can attest to that. She had a bug bite. A severe allergic reaction to a bug bite. Yes, your leg decided to do its impression of a balloon. All right. So today is going to be getting prepared for doing Lab 4, partially because there's this thing, there's a feature in programming languages called functions, and I am just, I just really want to get them out of the way, even though in the book they are all the way in, even though in the textbook they're all the way down here in chapter 11, and I'm trying to go through about basically 2 chapters a week. Actually, it's after dictionaries, which is totally unnecessary for us, but I'm going to teach them anyway. But I feel like chapter 12, we should teach them, and I'm trying to make sure that you can understand them in the context of everything. So this is what you're going to work on in the lab. If you have no idea what's going on at this point with that, that's perfectly fine. So let's go ahead and do that. So for each of the following problems, you're supposed to write a function that solves the problem. And then demo each function you write by calling it. So I go into detail here about how you can, to remind, and this will serve as a reminder about how you write a function. And then here's a link to also the assignment that I have over here. So currently and we're gonna learn functions in 2 parts. And I'm gonna go over both parts today, but primarily I'm gonna focus about how to write functions and putting things into functions. And I'm gonna leave how do I get stuff out of functions later? How do I return things from functions? And returning is very different than printing. And then my other hint is showing off how you can use different things with how you can modify how how print works with the sep and end arguments. So you've got 5 arguments that are going to 5 problems that are going to rely off of for loops or nested for loops. The first one is 99 bottles of beer, which is the song 99 bottles of beer on the wall, and I want you to basically ask the user for a number, and it will start at that number and print all the way down until it gets to 0 bottles of beer on the wall. Okay. Or if you prefer non-alcoholic beverage of your choice. It doesn't have to be beer. Okay. Multiplication table. So given a number, I want you to give me an n by n multiplication table. So if I give you 4, it's going to look something like this. If I give you 5, it uses something like this. And if you need to, and if you're having issues with the spacing, try using tabs. This one will most likely require a nested for loop. This one's fairly simple. This one's harder. Summation of squares. I'd say one's about as difficult as the first one. Write a function which, given an integer, does the sum of all the numbers squared from 1 to n. So if I give you 5, you should print out the sum of 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And now we have 2 ASCII art ones. The first is the Hourglass function. It's not going to take in any inputs in a function. What does that mean? I will show you. Let's see. I'm getting some chat. So, okay. You should print out the whole lyrics, and they will be printed, and the for loops will really help you with printing them out. Okay. This one, you want to basically write a code that will print out exactly this. But you'll want to use for loops to print out the spaces on the side and the semicolons. And then finally, you'll want something that draws ASCII art, but it will be different. But the art you draw will be different size based off of the input size. So But before we can really do that, we have to talk about functions and what are functions. So I've assigned reading for the textbook. They're not too bad. Specifically, the readings I assigned were 2.2, 2.3, and 2.4. So basically, and the introduction part, which doesn't really do too much. And they have some really good videos. So you can ask the user for an input. The videos, by the way, associated with this, as I just wanted to mention, were really good. But you'll be asking the user outside of the function, ideally. Like over here, this is a function that we write that will print out how many hellos, right? This is to print out how many hellos, the specified number of hellos. And what we do is we ask the user over here how many hellos they want. It is a difficult lab, I'm not going to lie, or it's difficult in the sense that it's time consuming. But I would highly recommend you ask your fellow students on Discord and ask me for help if you need it. It looks difficult mainly because we're using a lot of different things, but I've already had students who have demoed it to me. Granted, some of them have had prior programming experience, but I would highly recommend working on either the first one or the third one first. So, and again, this is stuff you're going to be getting help in lab tomorrow, but today we're going to talk about functions to get you prepared for that. Okay, so let's go ahead and VS Code. I'm going to boot up VS Code over here, and we are going to drag this over here somewhere else, so that's out of my way. Okay, and drag this out of the way too. Can you take my phone so it stops dinging, Annie?
I can.
All right, so let's go ahead and create a new file over here. And we're gonna call it, let's see, classroom. We're gonna put it into ITP, fall 2020. Let's call it function intro.py. All right. So a function is basically, so we've learned about how to create variables in Python, and we can do so by saying like x is equal to 5, that creates a new variable. Think of that as like creating a new noun that exists in our programming language, right? We've created a new integer there. Word is equal to this, right? And that's no problem. It just creates those variables. And let's see, let's run that. X is equal to 5, word is this. And then we can say, hey, what is word? And it says this. So we can create new verbs as well, new actions. We can define new things that the program can do. So let's just look at what a function is. Functions in some programming languages are also called procedures or methods, but we write new functions starting with def, the word def, short for define or define function. So let's go ahead and call this one print. Well, I'm going to use the example, print hello. And all it's going to, and this is the way a function looks. You start out by writing def, then you write the name you want to give this new command, and then you do open parentheses, and then if it takes any arguments, which we'll go into in a bit, we'll put those there. And then we do a colon to indicate that we're going to be putting stuff into it. So this one will just be called print hello, and I'm going to print hello, print this is inside a function, print is yet another line in the function. Okay. And so we've defined our function. And so if we run our code, let's see, it's, I think, Control-5 to run it. We run our code, it doesn't do anything because, of course, all we did was we just simply defined the function. We didn't actually, we just simply created it. We didn't actually use it. So to use a function, we say print, we just simply give it the name, and then invoke it. Sounds nice and magical and wizardly when we say invoke. So I like the word invoke. We invoke it, or call it if you prefer, using the parentheses to say this is a function and I want to call it. Now if it takes any arguments, which this one doesn't, you'll want to put them in those parentheses, just like any other function that we use. And so we notice over here that we've got hello. This is inside a function. This is yet another line in a function. So when we ran this, the code jumped over here. It ran this, then it ran this line, and then it ran this line. Everybody following so far? What's cool is, of course, is that this means that, and we can call this, it's not just a one-off, it's a new command. Right? I can keep using it. Done with the function, calling it again. Okay, and let's go ahead and run it. Right? So here we print it, we called print hello. Hello, this is inside a function. This is yet another line inside a function. Then we printed done with the function. And then I printed calling it again. And then we called it again. Of course, and there's nothing stopping us from doing doing this inside of a for loop. For blank in range 5. So this is going to do whatever. Remember, this means that we're going to do this inside of a for loop. 5 times, whatever's inside the for loop, we're going to perform 5 times. So I'm going to call print hello, and we're going to perform this 5 times. Oh, right. What did I forget to do? What did I miss? Parentheses. Yeah, parentheses, right? Gotta use those parentheses. So it printed it out 5 times. 1, 2, 3, 4, 5. So you can do those. So, I mean, now functions that don't take any arguments they exist. They're not hard to write. They're going to do the same thing no matter what. But if we suddenly provide an argument, we can do fun things. Actually, let's go ahead and write a different one. So just going to copy it, and I'm going to, well, why not? I'm going to just call def many hellos. And I'm going to pass in n. Okay? And now I'm going to say, first I'm going to say print the argument was n. So many hellos, I'm going to pass in 5. You're going to see. Why did I need the n? Well, because I'm writing something different that's going to require the n. So here, the argument was 5. Saying. So notice I passed in 5 and it said the argument was not n, but 5. Now I'm going to put in 10 and it will change it to saying the argument was 10. Now I'm going to change this to going to change this to num, and it'll fail because it'll say m was not defined. So the name of the variable, you can put in anything you want. The name of the variable matters in the sense that whatever you declare the variable to be, that's what's going to live inside the function. So here, many hellos, run this again, 10. We're going to go ahead and now emphasize this, print n. So notice here that basically I did many hellos. I said def many hellos n. The argument was n. So this crashing over here is to emphasize one thing. This n, which we define as an argument, exists. The name n exists only inside this function. Okay? Now we can use anything as an argument. I can say, I can make word. The argument was word. I can also do this, which will be a big focus of what we're doing today, because again, our examples being illustrative is pretty awesome. Import turtle, Bob is equal to turtle dot turtle. Okay. Many words, many hellos, Bob. So now if I run this again, there we go. You're not going to run it. Oh, right, because I was pressing Control-Shift F5. No attribute turtle. Oh, right. Due to circular import. What's going on here? Oh, yes, I had that example of not naming something turtle.py. So let's go ahead and remove that. And so it said the argument was turtle.turtleObject at memory location 0x017. So there you go. The argument here was n. It can be anything we want it to be. Now, what's the use of arguments? Well, we can do something pretty fun like this. Print hello. Let's give it a better number or a better name, repeats. Many hello, 5. So here I'm going to pass in many hellos, okay? 5 will get passed into repeats. And so we're going to replace repeats with 5s. With 5, so this is going to say hello 5 times. Hello, 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 hello. Make sense? Everybody follow? Did everybody follow this example? This was a bit of a jump, but everybody follow that. Okay, I've got an honest in the chat. So the idea here is that we gave it 5, so repeats, so we passed 5 into the function, okay? The 5 gets stored in the value repeats. And then we basically, anywhere we see repeats, we're gonna use 5 instead. Okay, so how did you pass 5 into repeats? By writing 5 or 10, and then saying I wanted to do it repeats many of times. So notice it did 10. because the 10 goes into many hellos, right? The argument was 10, and then the 10 gets replaced in the range over here. So I can specify that this function does different things when we run it each time. That's kind of the power of functions. It'd be kind of silly to have a function that just does something once. Yeah, think of it as, as Felipe says, think of it as replacing x for 5, like in algebra, right? Think of it as we're replacing the repeats with a 10, right? We did not choose the name function just, because we were sounding cool. We wanted to actually draw a similarity with mathematical, with basically the mathematical notations that we're doing. So if I were to, so I can change this to do as many hellos as I want.
Can I ask a question?
Yes.
If you were to put many of those repeats afterwards, after you put in the 10 or 100, what would happen?
If I were to put what, where?
Meaning if you type in many of those repeats.
If I were to do it like this?
No, like after you put in many hellos 100, does it define it for everything? And then if you were to put in many of those repeats after this line, would that give you the same number 100, or would it be whatever?
I mean, if I do 2 over here, are you saying that basically if I put in 2, is it going to be 2 forever?
Yeah, until you change it.
So functions essentially, once the function runs, it's gone. It doesn't have any memory of it running the previous time.
Okay.
Does that make sense? So here I'll do 2 and then I'll do 5 with a done in between. So it does 2 and then it does 5. Does that make sense? Okay. And not only that, right, if I try to print out repeats.
Yeah, that's what I was wondering originally.
Repeats doesn't exist outside of the function.
Okay, thank you.
Right, it doesn't exist outside of the function. It's only a variable that defines inside the function. This is a very important fact, and I'm going to spend the majority of our time on it today because it's very important that you understand that essentially the functions are where they are basically, they create their own little worlds where with their own little variables. So let's go ahead and take a look at Nathan, that is correct. Let's go ahead and take a look at our at something similar. So here I'm going to do print, and then I'm going to move on to a separate example. Okay, so let's go ahead and do many hello repeats. So we're going to do hello, and then we're going to do world, repeats number of times. So many hellos, 3. Hello, 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 world, world, world. Okay. All right. So let's go ahead and now try something over here. Let's go and say input. Let's make this interactive. How many times to print? I'm going to resimplify this. I'm going to take out, I just wanted to show you that we could do the indentation, as many for loops inside there as we really want. Okay, so how many times to print? Question mark space, and we're going to say n is equal to input and many hellos n. So we're going to run this. It's going to ask us, how many times do you want to print? How many times do you want to print? Let's also comment out the turtle for a second. How many times do you want this to print? And let's say we want it 10 times. Let's see, what did I say? Right, int input, right. I forgot to convert it to a string or from a string. So boom. How many times to print? Let's go 10. And it printed out 10 times. Notice that these variable names don't necessarily have to match, right? I've got 10, I took, why does what not to be indented? The n, because n is not inside the function. It's outside of the function. It's inside the main program. Only things that are part of the function need to be inside of the function. Right? That's how we know what's inside. So we know that these lines are part of print hello. We don't run them unless print hello is called. We don't run this code unless many hellos is called. And here outside, we need a place to be able to actually call stuff. So n into how many times do you want to print? We put in n. So notice that basically we put in 10 here. We replaced 10. We said, let's do many hellos 10. We took the 10 out of the n and basically passed the 10 right over here. Right. The number stored in n takes the number and repeats. Now, we can do something like this. We can name it the same thing inside and outside the function. There's nothing stopping us from doing that, because again, I want to emphasize that when we are inside a function, we are inside like our own little world, our own little mini program that exists on its own. Actually, Menachem, that is kind of the point I'm getting to. I want to try to avoid any confusion here. And we want to keep as little mental, when we're working in functions, and functions can sometimes get big. Sometimes we can have functions that share names and other functions, like, but so here we have int repeats, many hellos, repeats, right? Notice over here that basically that it still works. But the emphasis is that what happens inside a function is its own little world for the most part, okay? And there's some exceptions, but it's its own little world over here. So let's go ahead and see what happens now, right? So I'm going to go ahead, how many hello repeats? I'm going to print the value of repeats over here just to show you, print repeats. Okay, let's go ahead and run it. How many times to print? Print it out 10 times. It printed out 10. Now, let's go ahead and print. Sorry, not print anything, but now I'm going to do repeats is equal to repeats plus 1. So I just changed the value of repeats. Repeats in the function is
one question, it's probably a dumb question. Where is repeats right now? Is that in the for loop or is that in the function?
which one?
Repeats equals repeats plus 1. Where is that right?
That is outside the for loop inside the function.
Okay. Okay.
Right? It's inside a for loop. It would be inside the for loop if you did it like this. And that would be kind of terrible to increase. Well, actually wouldn't be too bad, I don't think. But because it creates range when it runs the first time. So, right, it's inside the for loop. In Python, it's very easy to tell. It's inside something if it's indented inside something. So let's go. So how many times to print? I'm going to say 3. Oh, yes, you can. You can use anything you want. It's just variable names. So I'm putting in 3. How many times to print? To print 3 times. We run this code, this hello code, 3 times. And then I say repeats is equal to repeats plus 1. So takes 3, adds 1 to it, and stores it inside repeats. print repeats in the function is 4. So we finished this code. We're outside of the function now, but it is repeats on the outside. It is 3 on the outside. Now that might be confusing, but let's go ahead and replace this repeats with num. And suddenly there should be no confusion about what the values would be on the inside and outside. They're right next to each other. Okay, hello, hello. Repeats in the function is 3, but it's 2 on the out, but num is 2 on the outside. All right, so so what's going on here is, again, I need to reemphasize this. What goes on inside a function is its own little world with its own variables. And the reason for this is that if you were trying, it would be very mentally taxing and very frustrating if I had to keep track of all the variables of what they were named outside of the function as well as inside the functions. When I'm working inside the function, I just want to keep track of what's inside the function, not what's outside the function. But think about the madness that would ensue if I had to keep track of all the variables all the time. Because then I would have to be aware of not just what my variables were named inside the function and outside the function, but in other functions as well. And not only that, in functions I would be importing. So none of that nonsense. If we change something inside a function, if we basically change what's stored inside a value in a function over here, then we just simply change what's stored inside of this function over here. Now, there are some caveats to that we'll get into, such as lists and other things that are mutable. But for the most part, this is true. And it works this way in almost every single programming language. Because we don't want to have to remember we don't want to have to worry when we're outside of a function what something is called inside a function. So remember, functions are their own little worlds, and you can name things whatever you want in the functions. All right? So now let's go ahead and start by doing by writing functions that are a bit more fun. Okay. So can the user call a function, or does it have to be called inside the function inside the program? If you're writing, you can write the function inside, line by line inside the idle editor or the command line. Like here, so here I just did that. Def many repeats. I just wrote this function over here, and then I can call it over here, many hellos 5, and it will do that. But anywhere else you can do, but I mean, most of the time we call it inside the main program. That's the main way we use it. So let's go ahead and write something that uses turtles. That will make our life, I think, a bit more easier because we're going to be, because turtles should be familiar at this point. Now I'm going to write a function that you're going to be seeing in the quiz. Now I wrote the quiz, but because the quiz will use functions, not necessarily have you write them, might have you finish some code in them, I wanted to make sure that it was locked, and I'm going to unlock it after this class. Okay. So def, so this is one of the functions that I use a lot in my quiz. Speaking of the quiz, 2 of the questions are then basically they involve turtles and for loops. 2 of the questions are parson puzzles, meaning you got to drag and drop things into the right locations. So that makes it so that helps. And then one of the questions you're going to have to complete. When does it due? I think next Wednesday. I wanted to give it plenty of time. I wanted to give plenty of the time, and the high holidays, the Jewish high holidays are over the weekend. So, is it available now? After this class. It says Thursday the 24th. I will make it. I'm not sure. I should have made it not visible. So I will make it visible. It's due next week, so you've got plenty of time on it. Anyway, but let me go over this thing that you're going to see in the quiz, which is draw square Bob. All right. So we're going to work on this. So basically, I'm going to write a function that uses a turtle. So here, what I'm going to do is that I've got my turtle. I've imported my turtle. Pass just means I want to fill this. I'm going to fill in the circle. I'm going to fill in the function in a second. And that the computer should not, the Python interpreter should definitely not panic that there's nothing in the indentation, because it's expecting stuff in the indentation because of that colon. So this is just simply a placeholder. It's going to get replaced almost immediately. You will never need to use it yourself. So we've got our turtle. I'm going to go ahead and drag the define this down here. Bob is equal to turtle.turtle. And we're going to say draw square Bob. Think of it as we're telling this turtle to draw a square. This turtle specifically Bob, right? Because I might have another turtle named Alice who might want to, that we might want to do. Okay, so let's go ahead and do, so how do we draw squares? Drawing a square is fairly straightforward. For blank in, I mean, I did define the turtle outside the function. This turtle is living outside this function. And then I just pass them into the function so that because I want to be able to use it with, well, you'll see in a second. So for blank in range 4. So, right, we're going to draw a square. Squares are 4-sided shapes, so we're going to do the following thing 4 times. And the advantage of doing it like this is that the turtle will end up in the same place and the same heading it started. So we're going to tell Bob to move forward. We're going to tell him to move forward 100, and Bob dot right 90. So now so basically we tell Bob to move forward and then to move right. Okay. And why did it just suddenly close? Anyone? I hear you, Laser. I'll be there in a second. Right, we need either exit on click or turtle.done to be able to because I'm not working in idle. Idle works a very specific way with that makes it so that the turtles don't close when we're using it. So turtle.done, this will mean that basically stay up. And again, turtle.done, if you don't have it in your assignment or your exam, I'm not going to care. That's one of the lines I don't care about. All right, so, and what's cool about this is that we can say, hey, we can have an Alice is equal to a turtle dot turtle. Okay. Okay, and then we can say Alice dot pen up. Alice dot go to is great. You can give it an XY coordinate. So let's go ahead and do let's say negative 100, sorry, negative 200. So negative 200 on the X, 200 in the Y. Alice dot pen down, and we're just gonna, again, big part of incremental changes, right? Let's go ahead and see what we wrote here. We said, let's create a turtle called Alice. Tell her to move her pen up. It's turtle.done because it's a thing in the turtle package that's telling it to hold on. Alice puts her pen up. Go to negative 200, 200. Put her pen down. And then we say, let's make a turtle called Bob. Bob needs to draw a square. Run this again. So that's Alice. Let's go ahead and make Alice a separate color so that we can tell the difference. Alice dot color red. Right? And now what's cool about this is I can say draw square Bob, draw square Alice, and run it. So then Bob's going to draw a square, and then Alice draws a square. Now you might be, again, looking at, wait a second, it says Bob to draw the square. But Bob here is just essentially the name tag that we're applying to the turtle inside the function, right? The Alice goes to the Alice and Bob are variables that are defined outside the function. We also have a separate Bob variable that exists only inside of this function. So it's essentially, this is a name tag that applies to both. So Bob is a name that essentially applies to Alice when she's inside this function. Questions on this? There's got to be some questions on this. I could make it easier by saying that I can say herp right? And again, this is just simply, think of it as wearing a separate name tag when they are inside this function, right? We pass Bob to the function first, then we pass Alice to the draw square. If you change the color inside, excellent question, Aaron. If I change the color of the turtle inside the function with the yes. So the variable, okay, this is what's important. And I think it's a great way to change it. So basically, right, this is the name tag. Think of this as the name tag that's applied. Herp is the name tag. So if I say herp dot color is blue, I'm saying whoever's wearing the name tag herp, change your color to blue. So Bob changes his color to blue, then Alice changes her color to blue, right? Mm-hmm. So what's going on here? Well, again, I said, think of this as a name tag, right? Even though herp only exists inside of here, we are still dealing with the same turtle. So some properties of the things you pass into this are mutable. So now what I mean, like when I say that some things only exist inside of this, let's go ahead and say if I were to create a, let's go, I have to play with this a bit to kind of show you. Let's say that I were to do herp dot, let's go ahead and say, hey. If I were to say herp is equal to a different turtle, okay, inside of this function, it doesn't mean that Alice and Bob suddenly no longer exist. It means that we've got a new, it means that basically that the name tag now, herp, now gets applied to this new turtle. All right, we're saying, again, it's always the thing on the right gets stored in the memory location over here. And essentially, the name herp stops applying to Alice and it stops applying to Bob. So right, we can, just like we can make the turtle move, we can make the turtle change color inside this function. Right? So the properties apply, so those change. Now when I say that thing, when I was talking about things having only existing inside of here, when we have this variable and we try to change it, notice we're using the equal sign over here to change what's inside of here. This basically makes a new number and stores it inside of repeats, right? So what I'm trying to say is that when you have a variable that's given a name in here, if you replace what's stored inside that variable, it's not going to replace what's stored outside of the variable. Does that make sense? Or outside the function. So if you've got a variable inside a function and you replace what's stored inside that variable, it's not going to change what's stored. It's not going to change what's stored in the variable outside the function. Your book has some really good diagrams that go into this. This is part of the reason I really like the book. And if you're confused about it, the best way I can say is that, again, the best way to learn how this works is through practice, 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 and you'll intuit how it works. Okay, and that's part of the reason why we have this specific layout. Now, let's go ahead and bring this into its quote-unquote final form as far as the way it's going to look in your quiz, which is going to take 2 arguments. When you have multiple arguments, they're separated by commas. So here I've got draw, perp, and size. And what's great about this is that we can pass in not just, so look at what we've done here. We say, hey, I want this turtle to draw something of a specific size. Now, if I try to run it now, it's going to crash because it's going to say, you were missing one positional argument, size. It's saying, you gave me the herp. You didn't give me size. Make sense?
Mm-hmm.
So now let's go ahead and give it a size. So let's tell Bob to draw a square of size 100, and we're going to tell Alice to draw a square of size 150 because, as somebody pointed out, they should probably remain socially distant. Right? So Bob was able to draw a square of size 100. Alice drew one of size 150 because the size function over here takes in a number. I mean, I don't know how the rule applies for turtles, so I don't know if 6 feet apart is what you need for turtles. I don't even know if turtles sneeze. That's something to ask my wife. She worked with reptiles and amphibians at the zoo. Could I use another word for size? You can use anything you want so long as it's the same thing over here. Right? Generally, though, it's good practice to use something that when you look at this again in 2 weeks, you're not like, what was I thinking? Why is it just a random jumble of letters? You want it to basically be easy to read. All right. So now let's go ahead and also show let's go ahead and just, what is the number for bigness? It was 100 for Bob and 150 for Alice. It's whatever we want it to be. Right, but what that is that defines how big I was drawing the square, how big each side was, right? Because this is a square, and I'm telling it to move, and I tell the turtle to move forward the amount I want a side to be, and then to turn right, and then to draw another side to be that length. Make sense? All right. So let's go ahead and draw a figure from the second best-selling video game of all time. What is the second best-selling video game of all time, by the way?
The Bible.
Legend of Zelda.
The video games. I don't think the Bible's a video game.
Tetris.
Tetris. Tetris is the best-selling video game, is the second best-selling video game of all time. It used to be the best-selling until it was knocked off its throne by what? Minecraft. Yes. Minecraft is currently the best-selling video game of all time. Yeah, my wife says, obviously, we need more games with blocks. Now, all right, so let's go ahead and draw what's the I-Tetrimo. Basically, so for those of you who haven't played Tetris, A, what are you doing with your life? But B, Tetris is you can play for free. Hey, how about that? So Tetris basically game with basically tetrimos, right? So here you've got basically these blocks fall. You try to make it so that you can fill up a line, and when you fill up a line, it clears. So here this I-Tetrimo will go in and it will clear out these 4 lines at the bottom. It's a great puzzle game. It can actually be played competitively. You should check out competitive Tetris. It is pretty interesting. So there are, I think, 7 different shapes for tetrimos, and the one I want to draw is over here, the eye. Now we'll be drawing. Now the tetrimos will feature in as part of the quiz, so there's a reason I'm doing this. But there's a lot of different clones. If you want to play it, it's perfectly fine. But all you need to know is that we just want to draw this 4-squared figure. So what we're going to do is we're going to define how do we draw the I-Tetrimo. So first off, when I'm defining the I-Tetrimo, I'm going to go ahead and define, I'm going to make it a bit more complicated than what you would see in your assignment, but I'm going to say, hey, I want Bob to draw it and size. And let's go ahead and be nice and tell myself in the future, what in the world am I drawing? Bob will draw a vertical tetrimo each, let's see, each of the 4 squares in the tetrimo will have a side length of size. Makes sense to everybody? So if I pass in 100, then we're going to have basically a square of 100 on top, and another square of 100, then another square of 100, then another square of 100. Now, drawing a square, now I just wrote a method to help us draw a square. So there should be no reason for me to repeat that. So what I'm going to do is I'm just going to draw 4 squares, right? So let's go ahead and say draw square. It's called Bob here, but it's called Herp there, but whatever. So we're going to tell Bob to draw a square. And let's go ahead and I'm going to do a multi-line comment over here. So basically that just commented out Alice. So comment this out. We've got Bob now, and we're going to say, Bob, hey Bob, we need you to draw, let's see, draw L tetrimo. No, not L, I tetrimo. Bob size. So actually size, we didn't define it. So if I ran it, it would crash. So let's go ahead and say 300. So tell Bob to run, and Bob draws a 300 by 300 square, a bit big. Let's go ahead and adjust that now. Now, obviously, this is not the end result we want. We want something a bit bigger. Oh, sorry, we want something that's 4 squares, one on top of another, all vertically. Okay, but this is thing to see that basically we called this function, and then we had the function call the other function. So acted as a middleman. So let's go ahead and now use this. So we need to draw 4 squares total. So that means we'll probably just need to call this 4 times. Now, obviously, if I just run this right now, it's just going to draw a square on top of each other, right? Because as I mentioned earlier, the way I like to write my square function is that if I am drawing a square, I want to end where it started and at the same heading. Now, the reason I like it like that is because, again, the less mental work I have to do, the better. Okay, so let's go ahead and think about this. So I drew a square, and now I want to draw another square below this. Let's go ahead and use the fact that I have a whiteboard to my advantage over here. So let's go ahead. So let's clear this canvas. Active pen, clear the canvas. So we have, and everybody can see this just fine? Okay, so we've got Bob over here. It's going to go ahead and, oh, so new messages. Okay, great. So 1, 2, 3, 4, and then Bob turns and he's facing this way now. Okay? Okay, so now what I want to do is I need to draw another square. Specifically, it needs to go like this. Dot, 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 dot. Bob needs to go here, then here. And yes, I know it's not a square, it's more of a rectangle, but whatever. But you get the point. So Bob is currently here and is currently here and he's facing to the right. So we need to draw another square. So when working with turtles, drawing is a great way to figure out what you need to do. So what we need Bob to do is to turn this way, which means turning right 90 degrees. Tell him to move down the length to move down to here, and then to turn left so that he's facing this way. All right? Make sense to everybody? So let's go ahead and boop, boop. Okay. So we need to Bob is facing this way. We need to move down. So that means Bob dot right turn 90, right? Bob dot right turn 90. So he turned right, which he was facing right. So turning to the right 90 degrees makes him face down, south. So now we need to move him down this far. We need to move this length down. Now, how far is that length? Well, it's the size of a side, which incidentally is size. Right, because we've defined how big that is. It's size. We tell Bob to move forward size distance. And then we tell Bob we want him to face the same way. So he's going to draw a circle, or not a circle, a square this exact same way. And so, and yes, Kristen, I am building up to that. So 1, 2, and then we draw 2 more squares because we haven't told them to. Let's go ahead and change this to actually something a bit smaller so it's actually going to fit on our screen. Or we can actually let's tell Bob, Bob dot pen up, Bob dot go to, let's go to, going to stay on the x-axis, and we're just going to tell him to move up 500, and then we're going to tell him to put his pen down so he doesn't. And this was just so that he wouldn't draw while he's moving. Okay. Can you? Somebody asked. Okay, interesting. What happened there? How come the turtle starts in the middle of the screen instead of 0, 0? What did I do wrong there? Bob.pet, oh, go to, let's see, is that too far up? Yeah, apparently that was too far up with the screen density. So somebody asked, how come this turtle starts at the center of the screen rather than 0, 0? Because turtles were meant to be accessible to anybody who's coming from algebra with Cartesian coordinates in their mind. So in Cartesian coordinates, right, Cartesian coordinate says, hey, you've got a grid, and this center point of the grid is 0, 0. So, and yes, somebody says, and yes, we're going to do a for loop for this, so just give me a second. Okay, so now the reason why this comes up is because in a lot of computer programs, just not turtles, because turtles are meant to be easy to learn and understand. Suppose this is your computer monitor over here. This over here, this point, that is 0, 0. And if I were to say, and if you, and y, increasing the y-axis goes down. So you can see why as a teaching tool, with turtles, we kind of want to start in the center. So, and again, 0, 0, the 0, 0 here at the center, it's for our Cartesian coordinates. So there's an invisible grid that your turtle's on. All right, so let's go ahead and keep going. So to make the turtle go down the next step, to draw the next square, we'll just do the same thing, and we'll do the same thing. 1, 2, 3, and then 4. And wait a second, as somebody pointed out, wait, if we're just copying and pasting a bunch of times, then we should just throw it into a for loop. For I in, no need for an I, for blank in range. It keeps saying that the size is not defined. Yeah, size has to be over here. Size has to be an argument. Or it has to, if size is not defined, maybe you're trying to call size down here where it doesn't exist. Or you haven't defined it up here as an argument. So we're just going to do, so anyway, to draw the eye treatment, we're just going to do this. Tell Bob to draw a square. Then have him turn 90 degrees to the right, have him turn down, move to draw the next, move him down to the next corner, top left corner of the square, turn him to the left so that he's ready to go again, and tell him, and then repeat. Oh, and I'm missing the very important colon. 2, 3, 4. And we can, that was obviously a bit too big, so we're just going to go and tell them to do 50. And there we go. So there we have Bob and the Tetrimo. Let's see. So any questions on this before I move on and do our reach goal for the day? Well, I can leave that for another time, but it is 3:08. Can I run it one more time? Yeah. So again, what we're doing over here is that we create a turtle called Bob. Well, actually, first off over here, we defined a couple functions. Print hello, many hellos, doesn't matter. We defined a function called draw square. I'll be sharing the code on GitHub. I'll be posting it on GitHub shortly. So def draw square, herp size for blank and range 4. Have it do this draw side of the square and turn right 90 degrees. So we have a draw square function. Then we defined an itetremo, which says, given a turtle in the size, draw 4 squares, essentially so that they get stacked on each other. Then in that case, I'll run this and then I'll go over that. So, and I'll mention what GitHub is. So 1, 2, 3, and 4. All right. So there we go. Let me go ahead and now upload this to GitHub. So, and I personally prefer to use a terminal, but that's my personal preference for this. So I'm going to just change directory into where I have this, which is Classroom. CD into ITP for Intro to Python. And let's see, git add star.py. Git, and then CD, we had fall 2020, that's where we were in. Just have to remember to do this, fall 2020. Git remove turtle.py because that wasn't there. Git delete. Whatever. Git commit -a to add all the stuff. Interesting, they didn't have that. Files for, okay. Git push to upload it. Git pull. Okay, there we go. Okay, yeah, so we've done a lot of stuff. I just still need to move some of the stuff into the folder. So GitHub is this wonderful tool. It probably is RM. So GitHub is this wonderful tool that Microsoft acquired a bit ago. It's named after this guy, Linus Torvalds. He is a Finnish-American software developer who is the principal creator of Linux, which is a Unix-based OS that he named after himself. He also eventually created a version control system called Git, which he named after himself. In a bit of self-deprecating humor. So Git is pretty awesome. It is free. It is open source. And GitHub is one of the most popular sites for storing, for basically storing things and it's one of the most popular hosts for Git and version control. And the big thing about version control, what is this? It's more than just basically having Google Docs. Right over here, I uploaded this, I merged it 2 minutes ago. So basically here's a bunch of stuff. So here we can click on ITP and we can see that basically we have different folders here. Fall 2020 is a bunch of stuff I just did over here. And we can see first functions, something we just, let's see, not first functions. Functions intro is something we just made over here. And there's the code that I have. But what's really cool is that what we can see in this, like this laptop guide that I wrote, over here, we can see a history. And it keeps track of the history of how this changed. And not only that, you can see we can browse files and we can see what the folder looked like and what the files looked like when it was like this, when it was before the last changed. So basically, it allows you to see versions as they change, keep track of changes as they happen. It is basically a tool that is designed to deal with that problem of two people need to work on some file at once, right? And that can get very frustrating. Anyway, I keep my code on GitHub just as a matter of practice because it's easy to upload and keep it the same between two computers. So you can find everything in the ITP, a lot of the code I do in class in the ITP Fall 2020 folder or on the top level. This is where I did a lot of stuff for the videos I've been doing. So, and if you need to find it, you can find it on our Canvas site, just like everything else. All the big important links are on the front page. All right, stop sharing. All right, I'm going to go ahead and stop recording. You're free.